So in this video we're going to look at an exam question on linear programming. So we're actually already given the inequalities of the problem here. So for example, x plus y is less than or equal to 30, 2x plus y is less than or equal to 40, etc. And the first thing we're going to do is we're going to turn these into equalities. So we're going to replace the inequality with an equal sign and then plot them on the graph. So we're going to plot the lines x plus y equals 30, 2x plus y equals 40, y equals 5, x equals 4, and y equals 1/2 x on the graph. So it's a little bit tricky for me to do on the computer, but I'll try my best. So the easy ones are the lines y equals 5, because that's a horizontal line going through the point y is 5, which I think is roughly around there. So it's not perfect on the computer, but we'll take that. Y equals 5, and x equals 4, which is a vertical line going through x is 4. So I think it's going to be about there. Okay. So this is x equals 4, because it passes through 4 here, and this one's 5 here. So this is the line x equals 4. And then we've got the trickier ones. Y equals 1/2 x. Well, that's a straight line going through the origin, because when x is 0, y is 0, and it has gradient to half. So, for example, when x is 20, y is going to be 10. So I think it's going to be about this line. So that's my line, y equals 1/2 x. And then, again, we know that because it goes through 0, 0 here, and it goes through, let's say, 20, 10, which is sort of that point. 2010 is on the line. Okay, now we have x plus y equals 30. Well, these are easy because in linear programming, all the lines are straight lines. So x plus y equals 30. We just need 2 points on the line to plot a straight line. So when x is 0, y is going to be 30, and when x is 0, y will be 30, and when y is 0, x is going to be 30. So it's going to go through this point 0, 30, and the point 30, 0. They're both points that satisfy that equation. So I just need a straight line through those 2 points. Again, it's a bit fiddly for me to do on this, but I shall do it. So I think it's going to be 45-degree line. So it's going to be roughly that. Great. So that's the line x plus y equals 30. And then finally we need 2x plus y equals 40. Well, same idea. When x is 20, that means y is 0. So the point 20, 0 lies on this line. And when x is 0, y is 40. So the point 0, 40 lies on that line. So I've done the two sort of spots that I know this is going to go through. I think it should be a line roughly like. Okay, so it's approximately this line. Again, it's not perfect on the computer, but hopefully you get the idea. This is 2x plus y. Okay, so we've drawn the equalities. We need to turn these into inequalities by sort of what we usually do is we shade out the region that is not allowed. So let's look at, again, the easiest one, x is greater than root of 4. So that means we're not allowing x is less than root of 4. So we look at the x equals 4 line and we're going to shade out the area that's not allowed. So we're not allowed x is less than 4. So we're going to sort of dash out the area to the left of that line. Okay, let's look at y is greater than root of 5. So we're not allowing y is less than root of 5. So we're going to dash out the area below that y equals 5 line. Okay. X plus y is less than 30. So let's take the x plus y equals 30 line, and we want to dash out the side that is greater than 30. Well, obviously, if x and y are big numbers, then x plus y is going to be greater than 30. So we want to dash out the side above that line. Okay, and we've got two more to do. 2x plus y is less than root of 40, so we need to dash out the greater than root of 40 side. So again, we're going to dash out this side, which is above that line. And then finally, y is greater than a half x. So we want to dash out the areas that y is less than a half x. So we look at the line y is a half x. Which side is less? When is y less than a half x? Well, it's when y is below that line. So we need to dash out below that line. Okay, so that leaves one area of the graph that isn't dashed at all, and that becomes our feasible area, which is f. Okay, so that's part A complete. In part B, it says use your diagram to find the maximum value of f on the feasible region in a couple of different cases. Well, the point with linear programming is that maximum and minimum values can only occur sort of at the corners of the feasible region. So we only have to ever look at the corners of the feasible region. So I'm going to label these in green. There's one here, there's one here, there's one here, there's one here, and there's one here. There's 5 corners. So we only have to look at those 5 points. Well, we should work out the coordinates of those 5 points. Well, let's look at, there's one that's the intersection of the line x is 4 and y equals 5. So that's the point down here, the point 4, 5. I'm not sure how easy that is to see. Okay, I've put it in, I'll just put it over the side here, 4, 5. So that's one point we need to consider. There's also this point that's the intersection of y equals 5 and y equals a half x. Well, y equals 5 and y equals a half x, so that point must be 10, 5. That point here is 10, 5. Okay. We also have the intersection of x equals 4 and, looking carefully, x plus y equals 30. So x equals 4 and x plus y equals 30. That means y must be 26. So that's this point here is 4, 26. Okay, we have a point here which is the intersection of x plus y equals 30 and 2x plus y equals 40. Well, these are two simultaneous equations. We can solve these easily enough. They have a solution when x equals 10 and y equals 20. So this is the point 10, 20. And if you've drawn the graph accurately enough, you can just read that off the axes as well. So we have 10, 20. And then the final intersection point is down the bottom, is the intersection of the two lines 2x plus y equals 40 and y equals a half x. So that means, so let's just scroll down a little bit. So we had 2x plus y equals 40 and y equals a half x. Again, they're simultaneous equations. We can solve them by substitution, or however you like to solve simultaneous equations. But combine these two, you get you get x equals 16 and y equals 8. Yep, that works. So this is 16, 8. So these are the 5 points that we have to check. So for each of these points, we just have to look at the value of 3x plus y and x plus 3y. So we can do this in a little table if we want. So in the first one, 3x plus y. So 3 times 4 is 12 plus y is 17. 3 times 10 is 30 plus 5 is 35. 3 times 4 is 12 plus 26 is 38. 3 times 10 is 30 plus 20 is 50. 3 times 16 is 48 plus 8 is 56. So which is the maximum? Well, it's this one. We're going to do the same for x plus 3y. So x plus 3y, when x, y is 4 and 5, we have 4 plus 3 times 5 is 19. We have 10 plus 3 times 5 is 25. We have 4 plus 3 times 26, which is 82. We have 10 plus 3 times 20 is 70. We have 16 plus 3 times 8, which is 40. Yeah, 40. So here's our maximum value for that. So going back to the question, the maximum of 3x plus y is 56 when x equals 16 and y equals 8. And our maximum for x plus 3y was 82 when x equals 4 and y equals 26. And that's the solution to this problem.